Hi math students, and welcome to your lesson on multiplying fractions. At this point we've spent some time talking about what a fraction is, talking about equivalent fractions or those equal fractions. In that last lesson you watched, you should have learned how to add and subtract fractions. The next operation we are going to learn is how you multiply fractions. Before we get into that, I've got our two review questions for today. The first one says Martin and Ronish's office is 10 feet by 12 feet. Jerica and Flora's office is 11 feet by 11 feet. Who has a bigger office? Justify your answer. All right. When we are talking about the size of something, so using words like how big is it, how large is it, which one has the bigger office, what you are referring to is area. We want to know the areas of the two offices and then compare those. The way you find area is you multiply the two sides. So often we see the formula area equals length times width. So to find the area of Martin and Ronish's office, we would do the 10 feet times the 12 feet. When you do that, that gives you 120. We need a measurement. When you're talking about area, I see the measurements feet. The way you measure area is feet squared, and you use that little 2 there for your squared. So this is the area of Martin and Ronish's office. For Jerica and Flora, theirs is 11 feet by 11 feet. When you multiply 11 times 11, that gives you 121. And then same thing, that would be feet squared. So if we wanted to answer who has the larger office, it looks like it's Jerica and Flora. For that justify, you could say something like pretty much what we just did. You could say the area of Jerica and Flora's is 121 square feet. Martin and Ronish's is 120 square feet. That's how I know that they have the bigger office. Some people actually find how much bigger it is. So I could say Jerica and Flora's office is the largest. It is 1 square foot bigger than Martin and Flora. Where did that 1 come from? Well, I subtracted those two numbers to figure out, well, theirs is 1 square foot bigger. Lots of different ways you could justify your answer. The other one we've got comes from our lesson yesterday. I'm asking you to do 1/2 plus 10/4. In order to add those fractions, I'm going to rewrite it over here as 1/2 plus 10/4. To add, we need the denominator or that bottom number to be the same. Right now it's not, so I'm going to have to change one. I'm going to change the smaller denominator to look like the larger denominator. So that 10/4 will be able to stay 10/4. And I'm going to change that fraction to have the same denominator so that they both have 4 as their denominator. In order to do that, we need an equivalent fraction. We need a fraction that's equal to 1/2. The way we'll get from this fraction to that fraction is I know 2 times 2 gives me 4. I'm going to do the same thing for our numerator. That top number, I've got 2 times 2 is 4, and then 1 times 2 is 2. 1/2 and 2/4 are the same thing. They just look different. So I've changed 1/2 to be 2/4 so that the denominators are the same. Then I can go ahead and add 2 and 10 to get 12. That denominator stays the same, so it would be 12/4. Looking at that fraction, I can simplify by dividing by 4. If I divide 12 by 4, it gives me 3. If I divide 4 by 4, it gives me 1. And we've learned that if the denominator is 1, this is saying you have 3 wholes, which is just 3. So we're reviewing a lot of stuff we've learned in that last lesson on adding and subtracting fractions with that problem. These were the two review questions. Now that we have finished those, we'll go ahead and get started with the lesson. Remember, we said this lesson here is going to be on multiplying fractions. So that objective is going to say, I can answer problems by multiplying fractions. Sounds like a plan. To get us started, I've got this fraction question here. It says Priscilla has a pan of 20 Rice Krispie treats. She wants to give half of the treats to her family. How many crispy rice treats could Priscilla give them? Draw a picture to support your answer. So looking through this, we've got a pan of 20 Rice Krispie treats. So she's made, I'll go ahead and draw it, since they say draw a picture. She's got a pan and there's 20 treats in there. So maybe she's divided it up into 4 columns and 5 rows. You could have drawn it differently. You could have maybe done like 2 by 10. This kind of goes back to what we learned with multiplying and drawing arrays, but I'm going to draw mine like this. So I've got, it's 5 by 4, so there's a total of 20 treats there. So she wants to give half of the treats to her family. So I want to figure out what's half of 20. That's really what we're trying to figure out here, is what is half of 20? Half of the 20 treats. Now you might already know that, or if not, you might be able to look at this picture and to figure out like, well, half of those 20 treats would be, we've got 4 columns right now, that would be 2 of those columns, like that, which would end up being 20, sorry, not 20, that would end up being 10. It's 10 treats. Now I'm starting with this one here because 1/2 is one of the easiest fractions to do math with. A lot of people can figure out what half of something is just by using a picture or just by using what you know about what half of something means. Now I want to show you that this one was pretty easy to do, but what if I had changed a half to 3/4 or 7/8 or some crazy fraction that we're not as familiar with? Using a picture might not help us as much as it did with the fraction being 1/2. So what I want us to know is what math you could do here to get the answer of 10. If we know that, then we would be able to do that math for any problem, even if the fraction is a little more difficult. The answer to that question is going to be what finding a fraction of a number means, which operation. If you want to find a fraction of a number, it is the same thing as doing that fraction times that number. So half of 20 is the same thing as half times 20. Now that's helpful because now I could do this math if it's a half or if it's a crazier fraction. Now the last part of this is, how do you do a half times 20? We know what the answer is already, but how do I get there? If I want to do a half times 20, I'm going to move over here. It is helpful when you are multiplying a fraction to actually have both of them look like fractions. So what I want to do is I want to help myself out by making 20 look like a fraction. It's like that review question we just did, but in reverse. Remember that review question earlier where I had 3/1 and I just wrote it as 3? If we go in reverse, if I want to make a number look like a fraction, I'm going to write it as 20/1. There's a couple ways you can figure that out. You can reason it as, well, 20 is the same thing as having 20 wholes if you're reading it like a fraction. Or remember, we saw this fraction line when we were learning about division. What this is saying is 20 divided by 1, and 20 divided by 1 is 20. Either way, if you are ever trying to make a number look like a fraction, you want to put that number over 1. Now the last part, I've got both my numbers looking like fractions now. Now all we have to do is multiply across. When I say across, I mean straight across like that. So I would do 1 times 20, which gives me 20. And then 2 times 1, which gives me 2. So I have 20 halves there. I'll come back and put that here, 20 halves. Now, just like with all these fraction problems, if you see something that you can simplify, go ahead and do that. So one way you could think of simplifying this is I see 20 and 2. I know I can divide both of those by 2. So let's do that. 20 divided by 2 is 10. 2 divided by 2 is 1. So we're left with 10 wholes. And we have already said before, if that denominator, that bottom number is 1, we don't need it. So we could just say 10. Notice that's what we said earlier. The other way you could do this, if you notice that top number is larger, if your numerator is larger than your denominator, you can also just think of this as division. This says 20 divided by 2. 20 divided by 2 is also 10. So a couple different ways you can get to that answer there. Either way, we've got our answer. She could give 10 of those treats to her family. You could use this picture to kind of help you reason that out, or now that we know how to do the math, you could use that math. Got a couple more that we're going to look at for multiplying a fraction and a whole number. This next one says 5/4 times 2. Our first step, just like with that past problem, is when you are multiplying a fraction, it actually helps to have both of them look like fractions. Now, I did something in that last problem to make a number look like a fraction. Do you remember what I did? We want to make the denominator 1. Remember that denominator is that bottom number? So my first step would be, I'm going to change this to say 5/4 times 2 over 1. I'm going to make that denominator 1. My next step is multiply straight across. I'm going to say 5 times 2 is 10. And then 4 times 1 gives me 4. Our last step is we can simplify. This is another fraction where there's a number you can divide both of those by. So I could look and say, well, 10 and 4, they're both even. Even numbers you can always divide by 2. So let me do that. 10 divided by 2 gives me 5. And 4 divided by 2 gives me 2. So we're left with my final answer is 5/2. That is all of my examples. I've got these 3 here for you to try. All right. The first one says 7/6 times 2. The next one says 3/5 times 5. For this one here, I really want to make sure you remember. When you do 3/5 times 5 over 1, you're left with 15/5. If you simplify that, that will give you 3 over 1, but make sure you're not putting 3 over 1 as your final answer. 3 over 1 is just the same thing as 3. This last one here says, in a class of 24 students, 5/6 are boys. How many boys are in the class? So for this problem here, they're saying 5/6 of the students are boys. But I want to answer the question, how many is that? That's what fraction of the class is boys. But if I were actually counting how many boys there are, how many boys are there? Well, to answer that question, we need to find, if we know 5/6 of the class is boys, I need to find 5/6 of the class, and the class is 24 students. So I want to find 5/6 of 24. In order to do that, we learned in that last problem that if you are finding a fraction of a number, that is the same thing as multiplying. So I could do, I'm going to put it up here just so there's more room. I could do 5/6 times 24 over 1. In order to do that, we would multiply straight across. Before I keep going, what number are we expecting to get? If there's a total of 24 students and we know 5/6 are boys, about how many boys are you thinking you're going to get before you do any math? Well, you should not be telling me a number more than 24. There's a total of 24 students, so I know my answer should be less. We can't have more boys. We can't have like 30 boys if there's only 24 students. 5/6, if 5 out of every 6 students is a boy, that means more than half the classes are boy. 5/6 is greater than 1/2. So that means more than half of these students are boys. So I also shouldn't be saying a number like 3, 4, 5. The majority of these students are boys. So maybe I want to guess like maybe 18, 19, 20, 21, around there. That would be a good guess. But let's go ahead and do the math now. I'm going to multiply this, same as for the other problems, I'm going to multiply straight across. So I want to do 5 times 24. I don't know if I know what that is. So we'll go ahead and multiply by hand. Remember, when you're multiplying like this, you're going to start with your 5 times 4, which gives you 20. I'll write down that 0 from the 20 and carry the 2. And then we can multiply again. We can do 5 times 2, which is 10. And then 10 plus that 2 you carried gives you 12. So we're left with 120. And then over 6 times 1. Well, 6 times 1 is just 6. When we go to divide that, you want to do 120 divided by 6. You can long divide, but there's a trick you can do here. I might not know what 120 divided by 6 is, but I do know what 12 divided by 6 is. 12 divided by 6 is 2. That means 120 divided by 6 is 20. And you could always check, remember, by multiplying these together. 6 times 20 gives you 120. To answer that question, how many boys are in the class? There are 20 boys. I also want to use this question as an opportunity to show you how you could draw a picture to go with it. So they told us there are 24 students. So I would want to come in and show somehow 24 students. Instead of doing a fraction of a whole, like I did with the Rice Krispie treats, remember we learned there's 2 types of fractions. You can have a fraction of a whole. So you can think of like a pizza, you're cutting up one pizza into parts, or you can have a fraction of a set. This question here is a fraction of a set. There is a set of 24 students, and some of those students are boys. We're not talking about like a part of a person as a boy. We're talking about a group of students inside this total is boys. So I'm going to draw my picture. I'm going to show there are 24 students. So I think I'm going to use X's to represent the students. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, okay, 24. They're telling me that out of that group of 24 students, 5, 6 are boys. Notice here that denominator is 6. Means I want to divide this setup into 6 parts. So I'm going to come in. I put it in 4 rows and 6 columns, so it'll be real easy for me to divide it up into 6 if I divide it this way. So right now it's divided into 2 groups, and I can come in and say, now I've got it into 6 groups. Group 1, 2, 3, 4, 5, and 6. They're telling me 5 out of those 6 groups are boys. So that means all of these are boys, 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 and all of these are boys. And this sad little group over here must be the girls. All of these students here are your boys. That part I just circled in red represents 5, 6. So to answer the question, how many boys are there? Well, I can count them all up. I can say, well, this is 4. So 4, 8, 12, 16, 20. Hey, look, it's the same answer we got. I'm definitely not saying that you want to figure out all of these by using a picture. I could have given you crazy big numbers. Maybe instead of 24 students, you know, high schools have a lot more, so maybe it's like 240 students. You don't want to have to be drawing a picture of that. But I do want to kind of show you the picture to go along with it to help make all of this math make more sense. With that, all of these problems, what they have in common is that you are multiplying a fraction by a whole number. There is one other type of multiplication problem. And after I erase all of this, we will look at it. For this next example, I've got actually 2 problems to look at. They look very, very similar. There's just a slight difference between them. So I'm going to go ahead and have us read through both of them. The first one says, Orlando has 6/8 of a pizza from dinner last night. He eats half of the pizza. How much did he eat? The second one, I changed it just a little bit. It says Orlando has 6/8 of a pizza from dinner last night. He eats half of the remaining leftover pizza. How much did he eat? The first question I've got for you is, what is the difference between these two problems? Don't worry about doing any of the math yet. Just reading through both of those stories, there's one small thing that's different. See if you can find what that difference is. That difference has to do with that second sentence. In this first one, it says he eats half of the pizza. And in the second problem, it says he eats half of the remaining leftover pizza. What is the difference between those two things? Or is there a difference? Well, when I say he eats half of the pizza, I mean he eats half a pizza. It means if this is what the pizza looks like and it was all cut up, he ate half of it. This right here is the part he ate. Yes, he started with 6/8 of a pizza, so he started with more than half, but he ate half the pizza. So to answer the question, how much did he eat? There's no math you have to do. It's just reading comprehension. How much did he eat? Well, he ate half a pizza. Done, easy. The difference over here is it's telling us he ate half of the remaining leftover pizza. It's this idea of he's not eating half of a whole pizza, he's eating half of something. Here, it's telling us he's starting with 6/8 of a pizza. 6/8 means that pizza was split into 8 slices, and he has 6 of those 8 slices left over. So he's got 1, 2, 3, 4, 5, 6. So when Orlando opens his fridge, that red part, that's what he's looking at. That's the pizza in front of him. This sentence here isn't saying he ate half a pizza. It's not saying this. It's saying he ate half of that remaining pizza. That red part he's looking at, he ate half of that. That is not the same thing as half of a pizza. What he ate here is he ate half of that leftover pizza. He ate half of the 6/8 of the pizza. Now I'm writing it like this for a reason. I'm writing it like this because this is very similar to what we were doing before. The difference is instead of half of the 20 Rice Krispie treats, we're now doing half of a fraction, half of that 6/8 of the pizza. Similar to what we were doing before, if you were trying to find a fraction of something, it's the same idea as multiplication. We want to do 1/2 times 6/8. Now these problems, when it comes to actually multiplying, they're almost easier than the problems from before, because before I had to go and worry about making them both look like fractions. Here they already are both fractions. So all we have to do is multiply. We could come in and say 1 times 6 is 6. 2 times 8 is 16. So we get 6/16. And then my last part would be simplifying this. So I can simplify 6/16. They're both even again, which means I can divide by 2. If I divide 6 by 2, I get 3. I divide 16 by 2, I get 8. And so I get the answer 3/8. In this problem, what does 3/8 represent? What does it mean? Well, the question was asking how much did he eat? He ate 3/8 of a pizza. Out of that whole pizza, not the leftover part, but out of the whole pizza, he ate 3/8 of it. Now, if we come back to that picture, I want to point out something. Remember before I had drawn this? This was that leftover pizza he originally had. There are 1, 2, 3, 4, 5, 6 slices. So think of it this way. Instead of with fractions, if you're looking at 6 slices and you eat half of those, well, half of 6 slices would be 3 slices. He ate 3 of these slices. So he ate that black part there. Well, what did he eat? He ate 1, 2, 3 out of the original 1, 2, 3, 4, 5, 6, 7, 8 slices. He ate 3/8 of that pizza. I chose this problem because this is one of the ones that's a little easier to draw. Not always are these fraction multiplication problems going to be this easy to draw. But I think it really helps, again, us see what's going on behind the multiplying fractions. With that, I'll go ahead and erase all of this. So there's one last example here. We got 3/4 times 2/5. In order to multiply those two fractions, what's the first thing we're going to want to do? Okay. Usually someone in class at some point in this lesson tells me, well, we want to make the denominators the same, because that's what we learned to do with adding and subtracting fractions, right? This is where I really want to point out, if you haven't noticed already, that is not the case with multiplying fractions. When it comes to adding and subtracting, we need those denominators to be the same because we're adding the parts together, subtracting parts. When it comes to multiplying, our first step is we're just going to multiply straight across. We do not need these denominators to be the same. And it's very tempting for students, especially when you're looking at two fractions, to want to go in and first change them to be the same denominator. But we don't need to do that when it comes to multiplying. Adding and subtracting, yes. Multiplying, no. So when we go to multiply these, I think I already said it, but our first step is going to be to multiply the numerators together and multiply your denominators together. So when I do that, we get 3 times 2, which is 6, and 4 times 5, which is 20. Final answer? Hopefully you're saying, no, Samantha, that is not our final answer because we have to simplify. So our next step would be looking at these numbers. Can we simplify? Yes, we can simplify by dividing by 2. If I do that, 6 divided by 2 gives you 3, and 20 divided by 2 gives you 10. I can't simplify 3/10 anymore. The only thing you can divide by is 1, so that is how I know I am done simplifying, and 3/10 is our answer. That is my last example. I've got these 3 here for you to try. The first one says 7/6 times 2/5. The next one says 9/4 times 2/3. And then that last question is our word problem. We've got there was 5/8 of a pie left in the fridge. Daniel ate 1/4 of the leftover pie. How much of the whole pie did he eat? For this one here, they're asking how much pie did he eat. I see he ate 1/4 of the leftover pie. He ate 1/4 of the leftover pie. The leftover pie, there was 5/8 of a pie. So he ate 1/4 of that 5/8 of pie. So I'm writing it like that to help me see that I really want to, I'm going to put it up here, do 1/4 times 5/8. When I multiply my numerators together, I get 5. When I multiply my denominators together, I get 32. 5/32. There is nothing you can simplify that one by. The only number you can divide both of those by is 1. If you tried, the only things you can divide 5 by are 1 and 5. 5 we can't divide 32 by. So that's a clue that you can't simplify it. That would be my final answer. I would want to put some words with it. The question asked how much of the whole pie did he eat? So I would say he ate 5/32 of the whole pie. Putting that of the whole pie is important because we know he ate 5/8, sorry, not 5/8. We know he ate 1/4 of the leftover pie, but that was out of the leftover part. We're talking about that whole pie, that original pie. He ate 3. I must need to go home because that's not a 3. But he ate 5/32 of that whole original pie. That is the last practice problem I've got for you guys. Thank you so much for watching. Hopefully you're feeling a little better about multiplying fractions. I personally like multiplying fractions because you don't have to worry about making the denominators the same way you do with adding and subtracting. So hopefully you're feeling like I am, that you like this lesson a lot more. But like I said, thank you so much for watching. This is our last lesson on fractions, so we are gonna go into a decimal starting tomorrow. Get ready. Bye guys.